Hi everyone, it's Miss Nerd. Welcome to my channel. Today we will be solving May 2020 Mechanics M1 paper. So let's start with question 1. Two particles P and Q with masses m and 2m respectively are moving in the same direction along the same straight line when they collide directly. Immediately before they collide, P is moving with speed 4u and Q is moving with speed u. Immediately after they collide, both particles are moving in the same direction and the speed of Q is 4 times the speed of P. So first thing as always, we'll draw out everything. So this is particle P, this is particle Q initially with masses m and 2m respectively. And they are moving in the same straight line in the same direction. So I'll consider this side. Immediately before the collision, P is moving with speed 4u, Q is moving with u. After collision, P, and again now here Q. They said immediately after they collide, both particles are moving in the same direction. So they are yet moving in the same direction. Their masses are same. And the speed of Q is 4 times the speed of P. So they did not give me either the speed of P or even the speed of Q. So for example, we're going to take P. We're going to consider P as V. Okay, the final velocity after the collision V. And as they said, Q is 4 times the speed of P. So this is going to be 4V. Now, part A says find the speed of Q immediately after the collision. So let's start with part A. So we'll as usual follow our equation m1u1 plus m2u2 equals to m1v1 plus m2v2. Okay, so m1u1 is going to be initially particle P. M1 is going to be M, this is going to be 4U plus, and M2U2 is going to be for particle Q, so it's going to be 2M, and its velocity is U, equals to M1V1 is now going to be the final for particle P. So its mass is M, and we considered velocity as V. And for M2V2, it's particle Q. So its mass is 2m and its velocity is 4v. Next we just have to simplify everything. 4mu plus 2mu is 6mu. This is going to become mv plus 4 2s are 8. 8mv is going to be 9mv. M and M is going to get cancelled. Velocity V is equals to 6u over 9, which gives me 2 by 3u. So this is the velocity for particle P, but particle Q is 4 times the speed of P. And so the velocity of Q is going to be V of Q is going to be 4V as we said. So 4 times 2 over 3U, which is the V, and so answer is going to be 8 by 3U. And that is our answer. Now, part B says find the magnitude of the impulse exerted by Q on P. So on P in the collision, we are going to consider everything for P. Now, for part B, impulse has the equation mv minus u. The mass of particle P was m. Its final velocity we found was 2 by 3u. And its initial velocity was 4u. If we simplify this, we get minus 10 upon 3 mu. Now, this is a negative answer, but they said they want the magnitude of the impulse. Remember that magnitude is always positive. So finding the magnitude of minus 10 by 3 mu, we are going to get 10 over 3 mu. I hope you got the point. This is the answer to part B. Now part C says, state clearly the direction of this impulse. Now, we consider always, according to me, the right side as positive. Either one of the side is going to be positive, so the other side is going to be taken as negative. Okay, as you can see, as we have taken positive to the right, all the velocities which we considered in the question A and in the part B have been taken as positive, because both the particles P and Q are moving to the right initially and even after the collision. So now the impulse we get is minus 10 by 3 mu. This is actually the real answer, okay? This is the real answer, minus 10 by 3. The positive 10 by 3 is just the magnitude. So when stating the direction of the impulse acting, you have to consider not the magnitude but the original answer which you find. So over here, as we get it negative, which proves us that part C, we got a negative impulse. It means that it's not traveling to the right, but instead it's traveling in the opposite direction. That's why we got negative here. Okay, I hope you guys got it. So for answer part C, it's just going to be opposite direction of motion. So that was the end of question 1. Let's move to question 2. Question 2 says a small ball is thrown vertically upwards with speed 14.7 meter per second from a point that is 19.6 meter above horizontal ground. The ball is modeled as a particle moving freely under gravity. Find A, the total time from when the ball is thrown to when it first hits the ground. So this question is basically for SUVET. So first we'll draw out everything. Consider the 19.6 meter as a building, okay? Imagine a building or a height of 19.6 meter. It's thrown from a height of 19.6 meter. This is our ball. It's going up and traveling down on the ground. This is the ground. And it's traveling with a speed of 14.7 meter per second. Okay, we have everything. Now let's start with part A. Part A says they want the total time is thrown and it hits the ground. Okay, so when a ball is falling down, we take the acceleration as positive. So as it is, and also as it is moving freely under gravity, that means acceleration is going to be equal to g. So acceleration is going to be g. Time is what we are searching for. We have the distance given 19.6. When an object is falling down, we take acceleration positive, but the velocity has to be taken negative. So my velocity is, they gave us 14.7. Instead, it's going to be minus 14.7. I hope you got the point. And now we are going to use the SUVET equation. S equals to ut plus half at squared. S is 19.6. My velocity is minus 14.7 t plus half g, where g is equal to 9.8 and t squared. form, I'll write it in the form of quadratic equation. Half gt square minus 14.7t minus 19.6 is equal to 0. Simplifying this, we'll get t value is equals to 4 seconds. Now, part B says that the speed of the ball immediately before it first hits the ground. So basically, they want the final velocity from us. So let's start again. Part B, acceleration, it's still falling down, so it's going to be still taken positive. My u initial velocity is going to be still negative. And final velocity is what we are searching for. We have s 19.6. Now we can use the SOVAT equation. V square equals to u square plus 2as, where v is what we are looking for. U is minus 14.7 squared plus 2g, s is 19.6, and this whole thing is going to be root. Simplifying this, we get the answer as 24.5 meter per second. And that is the answer for part B. Now part C states that the total distance traveled by the ball from when it is thrown to when it first hits the ground. Okay, so as they have said, the total distance, let's focus on the diagram. I'll show the diagram here. And so look at this. The ball is here, okay? And this is 19.6 meters, this whole thing until reaching the ground. But it has traveled this distance once and has reached the most highest point, and then again traveled that distance to reach the 19.6 meter height. So we have to calculate this height, multiply this by 2 because it travels this distance twice, and then plus 19.6 is going to give me the total distance. So let's start with our calculation. Part C. I'll write out to make it more simpler. So this is there. The ball travels up, reaches the highest point, falls back down directly to the ground, okay? So as it is moving vertically upwards, acceleration is going to be now negative g. My initial velocity is going to be positive 14.7, and the distance is what we are searching for. The final velocity at the highest point is going to be 0. Now we can use the equation v square equals to u square plus 2as, where final velocity is 0. 0 square is obviously 0. Initial velocity 14.7 the whole squared minus 2g, s is the question mark. Simplifying this, we'll get s is equal to 11.025 meters. Now, therefore, the total distance is going to be 11.025 into 2 plus the 19.6, which is going to give me 41.7 meters. And that is the answer to part C. Okay, so and then part D states, sketch a velocity time graph for the motion of the ball from where it is thrown to when it first hits the ground. State the coordinates of the start point and the coordinates of the end point of your graph. Okay, velocity time graph. Part D. First, let's start by drawing a graph. This is my velocity, this is my time. Please make sure to label the axes because they have marks. And now, this is the building from which it was thrown. It was thrown with an initial speed of 14.7. It traveled up, and then it reached a height where it's at its highest point, where the velocity becomes 0, and then it falls back down. And we had calculated the speed in part B with which it falls on the ground. That was 24.5. Let's draw the graph. Imagine this is 14.7. It goes and travels, and at some point the velocity becomes 0. This is when it is at the highest point, okay? And then again it's going to start increasing, but in the negative direction. If this is 14.7, 24.5 has to be a bit more lower than this. So take it more down. Okay, so this will be 24.5 minus 24.5. On to question 3. A particle of mass 10 kg is placed on a fixed horizontal inclined plane. The plane is inclined to the horizontal at an angle alpha where tan alpha equals to 3 by 4. The particle is held in equilibrium by a force of magnitude p newtons which acts up the plane, as shown in the diagram 1. The line of action of the force lies in a vertical plane that contains a line of greatest slope of the plane. The coefficient of friction between the particle and the plane is half. Find the normal reaction between the particle and the plane. Okay, so first what we're going to do is label out the diagram with all the forces acting on it. The weight always acts vertically down, okay? It's straight vertically down. This is the weight. And then the reaction force always acts perpendicular to the surface. My surface is this. So perpendicular to that will be this. This is my reaction force. And then we'll erase this part. Okay. And now we can see that as the weight is acting at an angle to the surface, there is going to be, components of the weight, one vertically downwards and one vertically to the left. This is going to be the angle alpha. And as alpha is connected to the vertical arrow, this is going to be cos. So this is going to be weight cos alpha. And this is going to be weight sine alpha. Okay. As P is making the ball move up, the friction is going to act this side, to the left. It's going to be frictional force. Now we are done with our diagram. Let's continue with the question. Find the normal reaction between the particle and the plane. As currently the ball is in equilibrium, that means total upward forces acting on the ball is going to be equal to total downward forces acting on the ball. The upward force is the normal reaction force, and the downward force vertical to it, like they're in a straight line, is W cos alpha. Not this weight, just weight is not possible, okay? It's either W sine alpha or W cos alpha. In this case, they have to be in a straight line and acting in the same plane, so it's going to be W cos alpha. So now, as it's in equilibrium, total upward force is going to be equal to total downward force. That's why R is equals to W cos alpha, okay? And then our weight is, the mass is 10, so weight is 10g cos alpha. As they gave us tan alpha is equals to 3 upon 4, tan alpha. So alpha is going to be tan inverse 3 upon 4, and if you type it out on the calculator, you get alpha as 36.9 degree. So now substituting everything into the equation and simplifying it, we are going to get R is equal to 78.4 Newton. So now starting with part B. Part B says find the greatest possible value of P, and part C says find the least possible value of P. Okay. So now let's get back to our diagram. When they say greatest possible value of P, we have to imagine that P is very joint, okay? Like imagine P is like acting 50 newtons, okay? So if it's that great, there are chances that this ball will start moving up, but in real life it's not, okay? It stays in equilibrium position, but we will assume that the ball starts moving up. And so if it starts moving up, friction is going to start acting backwards, right? Because friction always opposes motion. This is for when P is very giant, okay? And then when P is very small, it's still acting this way. Now imagine P is just 10 newtons, okay? So there are chances that now the ball is going to start rolling down instead of moving up. And so if it starts rolling down, the friction is going to act upwards. But as we know, in real life, they are still in equilibrium position. Please remember that they are still in equilibrium position. We are just assuming that it will either move up or it will either move down, and so the friction is going to act in different ways. So now starting with part B, it starts moving upwards, but in real life it's in equilibrium position. That's why all the forces acting to the right and all the forces acting to the left are going to be equal to each other. And so when friction, P is acting up, okay, and then it's W sine theta acting to the down and friction acting to the down. So P is going to be equal to friction plus W sine theta. P is equals to friction plus W sine theta, where friction is mu r and mu is half times r is what we found in part A, 78.4. W is the weight 10 g sine alpha. Substituting everything, we get P to be 98 newtons. So for part C, both P and the friction are going to act in the same direction towards the up, but W sine theta is going to be acting down. So it's going to be P plus F is equals to W sine theta. So P is going to be W sine theta minus F. Now substituting everything, it's going to be 10g sine alpha minus we have mu r again half times 78.4 Newton. And so the least possible value of P we get is 19.6 newtons. Question 4 says a non-uniform beam AB has length 8 meter and mass mkg. The center of mass of the beam is d meters from A. The beam is supported in equilibrium in a horizontal position by two vertical light ropes. One rope is attached to the beam at C where AC is 2.5 meters, and the other rope is attached to the beam at D where dB is equal to 2 meters. A gymnast of mass 64 kg stands on the beam at the point X. where AX is 1.875 meter and the beam remains in equilibrium in a horizontal position but is now on the point of tilting about C. The gymnast then dismounts from the beam. A second gymnast of mass 48 kg now stands on the beam at the point Y, where YB is 0.5 meter, and the beam remains in equilibrium in a horizontal position but is now on the point of tilting about D. The beam is modeled as a non-uniform rod and the gymnasts are modeled as particles. Find the value of M. The most important fact over here is that it is a non-uniform rod. A non-uniform rod has the center of mass not acting in the center. When it's a uniform rod, it would be actually over here. The center of mass mg would be acting here and it would be 4 meter this side and 4 meter this side. They would have the equal distance A to the center of mass and from B to the center of mass. But now the case is different. It could act either here, either here, either here. It could act anywhere. So for now, first let's draw out our diagram to know to write everything down. They say the weight I'm going to consider, imagine it's acting here. It's going to be mg. And they said it's d meters from A. So it's d meters from point A. Okay. And then they said a 64 kg gymnast stands 1.875 meters away from A. So as this is 2.5, 1.875 is going to be somewhere here. Let's take it here. And this is going to be acting downwards. 64 G, and this part is 1.875. I'll remove this. I'll write it with another color so that it's more understandable. This is 1.875 meters. Okay, so first let's deal with the 64 kg gymnast and then we will deal with the 48 kg gymnast. Okay. So, if we take movement about C, they said it's tilting about C. For the 64 kg gymnast, they said the condition is it's tilting about C. Tilting about C means the tension, there is a tension acting here and there is a tension acting here. But these are different tensions, okay? T1 and T2. So when they say tilting about C, it means that the tension, this T2, is going to be equal to 0. If it was a pivot, imagine this is C and this is D. So there is going to be a reaction force acting upward. If they would have said tilting about C, then the reaction force would be equal to 0. Please make sure to keep that in mind. And now let's continue. For now, they didn't say anything about tension, so we'll leave that out. We could take also moment about A, but as we don't have C, what is the reaction force? What is the tension, because it's a rope. We don't know what is the tension in the rope at C or at D. That's why we won't be able to solve it. But if we take moment about C, then we could easily solve it out because C is going to be not considered. The tension acting at C won't be considered, that we are going to ignore it because we are taking the moment itself about C. I hope that made sense. So now let's first take moment about C. Please make sure to write these terms because these are very important. Edexcel has this rule that you have to mention like which point you're taking it. So please make sure to write it down. So first let's consider moment C. Okay. So imagine this point is C. Okay. This point is C. Along C, we can see that mg is acting this side. Mg is acting clockwise and 64G gymnast is acting in the opposite direction. It's the anti-clockwise. If you see, this is 1, 2, 3, 4, 5, 6, and etc. etc. You can see this is moving your clockwise the mg is acting clockwise, but the 64g is acting anti-clockwise. So let's erase this now and let's continue. Okay. So 64g G is equals to 9.8 in mechanics. Please make sure it's not 9.81 like your physics. It's 9.8. 64g times the distance, because moment equals to force times distance. And the distance from 60c to 64g is 2.5 minus 1.875 meters, which is equal to 0.625 meters, into 0.625. Total clockwise movement is equal to total anti-clockwise movement. So this is going to be equals to mg times. Now again, you can see from mg to a is d and a to c is 2.5. We need this distance, right? So it's going to be d minus 2.5 is going to give me this distance. So let's write it itself as d minus 2.5. Okay, so g and g will be cancelled. And then if we simplify, we'll get 64 times 0.625 is 40 equals to m d minus 2.5. As we are finding m, let's make m the subject here. So our equation 1 is going to be m equals to 40 over d minus 2.5. This is our equation 1. Now, let's consider the second gymnast of mass 48 kg. Let's draw again. Okay. So they said from B, the 48 kg gymnast is 0.5 meters away. So as this is 2 meters, so around this might be 0.5. So it's going to be 48g, and this is 0.5 meters. Okay, now let's continue. Tilting about the point D. So tension at C is going to be 0 now. Let's continue taking moment about D. Now if I consider point D, this is example point D. The 48 kg gymnast is acting this side clockwise. 48g is acting this side, and the mg over here. Now for now, this everything is going to get erased because now the 64 kg gymnast is not standing anymore, as it's going to get erased except for the d. Okay, and the mg is acting anti-clockwise in this direction. What is going to be the distance from D to M? We know that this part is 2 meters, right? So let's imagine that this part is no more there. If we consider, now if we want this part, it's going to be 8 minus 2 is going to be, this part itself is only 6 meters. And from here to here, it's going to be 6 minus D. I hope that made sense. Now let's continue. 48g clockwise movement. First let's consider 48g times 2 minus 0.5. It's going to be 2, and then this part here is going to be removed. We want only this distance. So it's going to be 2 minus 0.5, which is 1.5 meters, times 1.5, which is going to be equals to mg times 6 minus d. So again, g and g are going to be cancelled. 48 times 1.5 is 72. 72 is going to be equal to m6 minus d. Again, making m the subject, we're going to get the second equation, 72 over 6 minus d. This is my equation 2. Now, as both of them are m, we can equate equation 1 to equation 2 and simplify it to get the value of d. So 40 over d minus 2.5 is equals to 72 over 6 minus d. Cross multiplying them, it's going to become 40 times 6 minus d is equals to 72 times d minus 2.5. 40 times 6 is 240 minus 40d equals to 72d minus 180, because 72 minus 2.5 is 180. Now let's make all the d terms together. 240 plus 180 is going to be equal to 72d plus 40d. 240 plus 180 is 420 is equals to 72 plus 40d is 112d. And so d is going to be 420 divided by 112, that is 3.75. And now, as I've got d, now I can substitute 3.75 into either equation 1 or equation 2 to get the value of m. So I'm going to substitute in equation 2. So it's going to be m is equals to 72 divided by 6 minus 3.75, which is going to be equal to 32 kg. And that is the answer. Question 5 says a particle P is moving in a plane with constant acceleration. The velocity v meter per second of P at time t seconds is given by v equals to, the equation as they said. Find the speed of P when t is equals to 2. So the first thing we have to do, this is velocity equation. The given equation is for velocity. Speed is the modulus of velocity. So now first let's substitute into the velocity equation t equals to 2. A says v equals to 7 minus 5 2s are 10. I plus 12 2s are 24 minus 20 j. Simplifying this, we'll get minus 3i plus 4j. As it is the modulus of velocity, now speed is going to be equals to root minus 3 squared plus 4 squared, which is going to be equal to 5 meter per second. Please don't forget the units. Units have marks. Now part B says find to the nearest degree the size of the angle between the direction of motion of P and the vector j when t is equals to 2. Now with part B, let's first draw a rough diagram. Direction of motion of P means the velocity. Okay, let's consider the velocity, the angle between the velocity vector and the vector j. This is the vector j, this is the vector I. So we had gotten velocity after substituting 2 minus 3i plus 4j. So minus 3 is going to be somewhere here, so it's going to be minus 3, and 4j is somewhere here. Okay, and they want the angle between the vector j and this, the directional vector of P. So for finding this angle, first we can find out this small angle, and then we know that this is 90 degree. So if I subtract from 90 the theta value which we find, we are going to find the angle which we need. So we can use tan theta. Tan theta is going to be equals to opposite by adjacent, that is 4 over minus 3. You're not going to include minus 3 when taking the angle. This is my way actually. I usually consider it always positive. Or even if it's minus 3, I'm going to take it as positive. And so you will get theta is going to be equals to 53.13 degree. So 90 minus 53.13 is equals to around 37 degree. And so that is our answer. Now part C says the constant acceleration of P is a meter per second square. Find A in terms of I and J. So from physics or from basic IGCSE, we have learned that part C, acceleration is equals to v minus u by t, where v is the final velocity, u is the initial velocity, and t is the time taken. Minus 3I plus 4j meter per second, right? So now I need u. I don't have any u. They did not say me that it started from rest. Otherwise, we could have considered it as 0. But now what we can do is we can find another velocity by substituting t equals to 1, and then we get an initial velocity, a velocity which is before t equals to 2. First, let's find when t equals to 1, what was the condition. We had the velocity equation given to us, which was 7 minus 5 times 1 is 5i plus 12 times 1 is 12 minus 20j. Simplifying this, we are going to get 2i minus 8j. Now we have when t equals to 1, it's 2i minus 8j, and when t equals to 2, it's minus 3i plus 4j. Now if we substitute this into the acceleration equation, v, so first we are going to substitute t equals to 2, so minus 3i plus 4j minus 2i minus 8j. The whole thing divided by 1, because t equals to 2 and t equals to 1. 2 minus 1 is 1. So simplifying this, let's make all I terms together. Negative 8 and negative is going to make it positive 8j. And simplifying it further, we are going to get it as minus 5i plus 12j. And that is the answer. Now, part D says find the value of t when p is moving in the direction of minus 5i plus 8j. Let's do D here. Part D. So when they say moving in the direction of a specific vector, it's going to be the velocity with which it was moving. We got a velocity equation, right? 7 minus 5ti plus 12t minus 20. We have this equation. It's going to be now equal to a common multiple of the vector minus 5i plus 8j. So let's keep that common multiple k. It's going to be minus 5i plus 8j. So now if I make all the I terms together, it's going to be 7 minus 5t is going to be equal to minus 5i times k is going to be equals to minus 5k. Now making k the subject, we get the equation 7 minus 5t divided by minus 5. And then making all the j terms together, we get 12t minus 20 is going to be equals to 8j times k is 8k. Making again the k the subject, it's going to be 12t minus 20 over 8. As both are k terms, we can equate them to each other. 7 minus 5t over minus 5 is equals to 12t minus 20 over 8. Cross multiplying them, we get 8 times 7 minus 5t, which is going to be equals to minus 5 times 12t minus 20. 8 times 7 is 56. 8 times 5 is minus 40t, which is going to be equals to 12 times minus 5 is minus 60t. Negative 5 into negative 20 is plus 100. 56 minus 100 is minus 44. Minus 60 plus 40 is minus 20t. Negative and negative are going to get cancelled, and so we're going to get t is equals to 2.2 seconds. So now question 6 says a railway engine of mass 1500 kg is attached to a railway truck of mass 500 kg by a straight rigid coupling. The engine pushes the truck up a straight track which is inclined to the horizontal at an angle alpha. The coupling is parallel to the truck and parallel to the direction of motion. The engine produces a constant driving force of magnitude d newtons. The engine and the truck experience constant resistance to motion from non-gravitational forces of magnitude 1200 newton and 500 newton respectively. The thrust in the coupling is 2000 newtons. The coupling is modeled as a light rod. Part A says find the acceleration of the engine and the truck. So now let's start marking up our diagram. Zoom in. I'll write with two different colors so that it's easier to differentiate. This is the engine and then this is the truck. Okay. Now starting with the truck has some mass of 500 kg and the weight is going to act vertically downwards, and as it's at an angle there is alpha acting here. This weight is going to have components, which is the weight cos theta and the weight sin theta. So let's remove this and now so this is going to be theta. This was 500, so 500 g cos theta, and this is going to be 500 g sin theta. There is a normal reactive force acting, which I'm going to give as N, and it has a resistive force acting as well, which is 500 newton. Okay, like this. Alright, now moving on to the engine. Its weight is actually acting vertically downward, but as it's acting at an angle, so it also has components. So its components are going to be like this: 1500 g cos alpha and 1500 g sin alpha, because this is alpha. And I'm going to give the reactive force, normal reactive force, as R over here, because we don't know whether N and R are equal to each other, so let's give them separate alphabets. And it also has a resistive force acting on it, which is about 1200 newtons. The thrust acts towards each other, okay? But if they said it had tension, then it would look like this. Okay, I hope that made sense. But now as it's thrust, it's going to be towards each other, which is of 2000 newtons. Okay, now everything has been drawn out. Now let's go to the question. They said find the acceleration of the engine and the truck. So now what we can do is either we can consider both particles as a single particle, or either we can consider only the truck and the forces acting on the truck, or the forces acting on the engine. So I'm going to take only the truck and show you guys how to solve it. So part A, we know the equation resultant force is equals to ma, right? We have the mass, we need to find the acceleration, so let's find the resultant force. For the truck, the forward force as it is moving upwards, right? It's moving upwards, which means that the 2000 Newton force acting forward is much more higher than the forces acting backwards on the truck, which is the 500 Newtons resistive force and the 500 G sine alpha, which is the component of weight acting to the left. Okay, so now let's add them up. Okay, so resultant force is going to be 2000 newtons minus 500 plus 500 G sine alpha, which is going to be equals to ma. The mass of the truck was 500 and the acceleration is what we need. Now sine alpha, they have already given us sine alpha is equals to 7 over 25. So instead of sine alpha, you will substitute 7 over 25. G is equals to 9.8. And then if you simplify this, we'll get acceleration is equals to 0.256 meter per second square. I'll repeat again, please don't forget the units. Part B says find the value of D, because I forgot to show D, right? D is the driving force of the engine, which is going to be acting to the right. So if we consider the single particle, the forward forces acting are only D. Okay, you can say that, oh, there's 2000 newtons acting to the right over here. Why is this not included? Because when I considered a single particle, the thrust cancels out each other, and if it was tension, then it would also cancel out each other. This is a very important point. Students usually tend to do mistakes here. Please be careful about that fact. So let's erase this and let's continue. Okay, now part B, the forward force acting is only D, and then minus, it's going to be 1200 Newton, the resistive force of the engine, plus the resistive force 500 Newton of the truck, plus the component of the weight of the engine, and plus the component of the weight of the truck. These all are going to be equals to MA. 2000, 1500 plus 500 is 2000 times the acceleration 0.256, which we found in part A. Remember the fact that the engine and the truck are going to have the same acceleration. Simplifying this entire thing, we are going to get D is equals to 7700 newtons. Question 7 says, one end of a light inextensible string is attached to a particle A of mass 5m. The other end of the string is attached to a particle B of mass 3m. The string passes over a small, smooth, light fixed pulley. Particle A is held at rest with the string taut and the hanging parts of the string vertical. Particle A is released. We know that 5m is greater than 3m. We can figure that out, right? So first let's mark out the forces again. There's going to be tension acting obviously upwards and here as well. The tension of A and the tension of B are going to be this time equal to each other because they're connected to the same rope, okay? And there's going to be weight acting 5mg and here 3mg. Okay. So forces are marked. Now part A says find in terms of M and G the magnitude of the force exerted on the pulley by the string while A is falling and before B hits the pulley. So basically what they want is the tensions. Both the tensions are going to be acting towards the pulley, right? So these are the forces acting on the pulley. So let's start with part A. We can make out some equations first. As 5 mg is falling down, it proves us that the weight is bigger than the tension for particle A. And so resultant force is equals to ma. So we can make out the equation 5 mg minus the tension T is equals to 5 ma. This was my equation 1. And now equation 2. Equation 2, the ball B is moving up, which proves us that the tension for ball B is greater than the weight acting. So we can make out the equation now. T minus 3 mg is going to be equals to 3 ma. This is my equation 2. 5 mg minus T is equals to 5 ma minus 3 mg plus T is equals to 3 ma. Plus T and minus T are going to be cancelled. So what we are going to get is 5 minus 3 is 2 mg and 5 plus 3 is 8 ma. The m and m are going to get cancelled. 2 divided by 8 is 1 by 4. And so it's going to be 1 by 4g is the acceleration. I'm not cancelling out g because they said find in terms of m and g. Now if I substitute the acceleration into one of the equations which I found, equation 1 and 2, I can get an equation for the tension. So I'll substitute in equation 1, 5 mg minus T is equals to 5m times 1 by 4g. So T is going to be equals to 5 mg minus 5 over 4 mg, which is going to be equals to 15 over 4 mg. Now if I multiply this times 2, the resultant force is, because we said, right, the tensions, both the tensions adding up is going to give me the resultant force acting on the pulley. So it's going to be 2 times 15 over 4 mg, which is equals to 15 over 2 mg. And that is the answer. Then part B says state how in your solution in part A you have used the fact that the pulley is smooth. So we have stated, I have repeatedly stated the fact that the tension acting on both sides of the pulley is equal. That is how we have used the fact that the pulley is smooth. Okay, these are some fixed answers. I hope you guys learn them by practicing lots of papers and you get to know on the specific questions what specific answers you should state. The answer is going to be tension on both sides of pulley is equal. Question 8 says the acceleration time graph shown in figure 5 represents part of a journey made by a car along a straight horizontal road. The car accelerated from rest at time t equals to 0. Part A says find the distance traveled by the car during the first 4 seconds of its journey. So now first let's try to find out the velocity with which it was moving at t equals to 4. Part A, acceleration is equals to v minus u over t. Acceleration is given to us over here as 3 according to the diagram. Its final velocity is what I want, and they say that it started from rest. From rest means u is equals to 0 and time t taken is 4 seconds. So it's going to be 4. So finally v is going to be equals to 4 3s are 12 meter per second. Alright, we want the distance. So we have acceleration, that is 3 meter per second square, velocity, which is 12 meter per second. The time taken is 4 seconds, and what we want is s, the distance. Use the so-that equation s equals to vt minus half at squared. Okay, so my final velocity is 12, time taken is 4, minus half, the acceleration is 3, time taken is 4 squared. Simplifying this, we get the distance to be 24 meters. And this was the answer to part A. Now part B says find the total distance traveled by the car during the first 26 seconds of its journey. So this we got to be 24 meters. Okay, now we will use the same methods for both this and this. Alright, let's move on here. Okay, part B, we know we are finding s, that is question mark. Okay, and then they said it's 24 minus 4, the time we got is 20 seconds, and you can see it's moving with 1.5 meter per second square, that is the acceleration. And as it was at this point moving with, we found it to be 12 meter per second, right? So over here it's moving with a different velocity, so this is going to change from v to u in this case. I hope you guys understood. Now this is going to be the initial velocity with which it was traveling, and then it decreased to some other velocity. I hope you guys understood what I meant. So let's continue. Acceleration, we found it to be 1.5. Time taken, we found it to be 20 seconds. And the initial velocity to be 12 meter per second. Use the equation now, s equals to ut plus half at squared, where my initial velocity is 12, my time taken is 20, plus half, my acceleration is 1.5, and again my time is 20 squared. If I simplify this, I'm going to get it to be 540 meters. Now I'll erase this part. Okay, and this we found it to be 540 meters. Now for the third part of the stage, we have the acceleration minus 4. We know the time is 2 seconds. Here we used the fact that we knew the initial velocity, but for this case we have no initial velocity found, or the final velocity with which it is traveling. So first we'll find the velocity with which it was traveling when it traveled 540 meters. That will be our initial velocity for this case. Okay, we know that v is equals to u plus 80, right? And it was traveling initially with 12, u plus acceleration 1.5, and time t was 20, and I get it 42 meter per second. Now this is going to be my initial velocity for the third part. We are finding s. I have the initial velocity to be 42 meter per second, my acceleration to be minus 4 meter per second square, my time to be 2 seconds. Again, I'm going to use the equation s equals to ut plus half at squared. My initial velocity is 42, my time is 2, and it's going to become minus half. 4 is acceleration, and the time is 2 squared. Simplifying this, I get this part to be 76 meters. Now, as they say, the total distance it's going to be the addition of all the three paths, right? The first path said it traveled 24 meters. The second path said it traveled 540 meters. And now the third part says it traveled 76 meters. Adding all this, we get the total distance to be 640 meters. And that was the end of the paper, guys. If you have any doubts, please feel free to comment and let me know. I'll try my best to help you guys out. If you liked my video, please subscribe, like, and comment on which videos you want next. Thanks for watching.